This video is a quick guide on the LINQ Sum method. Similar to our previous discussion on the average method, the sum method is a fundamental tool in LINQ for data manipulation. It's widely used for calculating the total of numeric values in a dataset. Whether you are a beginner or an advanced programmer, understanding the sum method is crucial for efficient data processing. Let's explore how this method simplifies adding up values in various data types, from simple arrays to more complex structures. Like the average method we talked about before, sum adds up numbers for you. It works with all kinds of numbers, whole numbers, decimals, and even the ones with fractions. Now, sum can do its magic in two main ways. The first way is super simple. If you have a list with just numbers in it, like a shopping list with prices, you can add sum at the end, and it quickly gives you the total cost. The second way is a bit more advanced using a lambda expression. This is great when your list has things other than just numbers. Imagine you have a list of words and you want to know how many letters there are in total. With a lambda expression, sum can look at each word, count the letters, and then add all those counts up. The number sum gives back to you will be in the same type as your list, unless you tell it otherwise. So, if your list has whole numbers, sum will give you a whole number back. It's usually best to stick with this, so if your list is all whole numbers, use a whole number to keep your total. In short, sum is like your math buddy in LINQ. It can handle different types of numbers and can even work with more complicated lists, all to give you the total you need. Let's now start with the examples and check the first one. Consider an array of integers. By applying the sum method to this array, we calculate the total sum of its elements. This usage showcases the most straightforward application of the sum method. Moving to a slightly more complex example, imagine we have a list of strings, and we want to find the sum of the lengths of these strings. We can achieve this using the sum method with a lambda expression. This approach demonstrates how the sum method can be adapted for non-numeric data types by focusing on a numeric property, in this case, the length of the strings. For a more advanced scenario, consider an XML file containing product data. We can use LINQ to XML to parse this file and then apply the sum method to calculate the total price of all products. This example highlights the method's flexibility with different data structures. In another advanced use case, let's consider a data table filled with financial data. We can convert this data table to an enumerable collection, and then use the sum method to compute the total of a specific column, such as the price or cost. Just like with the average method, we can combine sum with other LINQ methods and clauses to meet various requirements. However, it's important to note the behavior of the sum method in different scenarios, particularly when dealing with null sequences and empty sequences. Imagine we have an array of integers named numbers. Let's say we filter this array to select only numbers smaller than 3. If no numbers in our array meet this condition, we end up with an empty sequence. When we apply the sum method to this empty sequence, the result is 0, because there are no elements to add up. Now, consider a different situation where our array, numbers, is set to nothing, meaning it's null. If we try to use the sum method on this null array, VB.net will throw an argument null exception. This shows the difference between dealing with an empty sequence, result is 0, and a null sequence, results in an exception. Moving on to understand the differences between various LINQ aggregation methods, let's consider the following aggregation methods. These methods react differently when faced with a source that contains no elements or when the source is null. When the source contains no elements, sum, count and long count return 0. This is because there's nothing to sum up or count. The other methods throw an invalid operation exception. This is because these operations can't compute an average or find a maximum or minimum value in an empty set. On the other hand, if the source is null, all these methods will throw an argument null exception. This is because you can't perform any operations on a null source. Understanding these differences is key to effectively using LINQ aggregation methods in VB.net. Knowing how each method behaves with empty and null sources helps in writing robust and error-free code.